Alrighty, so this is the 6.1 notes titled Angles of Polygons. Alright, so we have a couple of definitions up at the top. A polygon is just a plane or figure with at least 3 straight sides and angles. Remember from chapter 1, we learned that in order to form a plane, we need at least 3 non-collinear points, right? 3 points not on the same line, which forms a triangle. So the very first polygon is a 3-sided figure. Okay, so 3 sides or any more sides after that forms a polygon. Okay, so most of them will have a name up until about 11 or 12 sides, and then we start calling it like 13 gon, 14 gon. You'll kind of see that later in the notes. But here we have a triangle, 3 sides, quadrilateral, 4 sides, pentagon, 5, hexagon, 6. So what we will be looking at is something called a convex polygon. So don't let the word convex scare you. All it means is that the vertices point outwards, okay? So like all of our vertices, which are the corners, they are pointing outwards. They're not pointing inwards. Something that would be pointing inwards, or it's called concave, is like a star. Okay, yes, we have vertices that are pointing out, but we also have vertices that are pointing inwards. Okay, that's concave. We are only going to look at convex, which again, don't worry about that definition. The definition that you do need to remember is called regular polygon. Okay, when you see the word regular, it means that all sides are equal and all interior angles are congruent. Okay, so if we have a triangle where all of my sides are equal and all the angles, the interior angles are equal, then it has to be the equilateral triangle. If we have a quadrilateral, 4 sides, where all sides are equal and all angles are equal, then it has to be a square. Okay, so regular, all sides are equal, all interior angles are equal, so that's important. So we know that the sum of the interior angles of a triangle is equal to 180 degrees. We learned that in chapter 4. It says to complete the table below and look for a pattern to discover the sum of the interior angles of any convex polygon. Okay, so we're going to do a few. We won't do this entire table just for the sake of time for this video. But the first figure or polygon that we learned has to have at least 3 sides, which is called a triangle. Okay, and a triangle only has one triangle. We know the sum of those angles inside are 180 degrees. Okay, and if then we look at one angle, okay, this column right here only applies to regular polygons. If we are finding just one interior angle, right, then it has to be regular in order for them all to be the same, right? Because we could have, if we just are looking at interior angles of any kind of triangle, then those could vary, right? Not every single triangle had the same exact angle measures. So when we ask for one, it has to be a regular polygon. So we know if it's regular, it's the equilateral triangle, which every angle in an equilateral triangle was equal to 60 degrees. Okay, the next polygon that has 4 sides is called the quadrilateral. Okay, if I take a quadrilateral up here and I draw a diagonal, okay, there's 2 triangles in a quadrilateral. Okay, I know we can draw another diagonal, but we're trying to find the minimum, right? Minimum number of triangles in a figure, so minimum would be 2. Okay, in a quadrilateral, if I have at least 2 triangles, right, minimum of 2, then the sum of those angles, 180 plus 180, would be 360. Okay, so think about it. Every quadrilateral, or a full circle kind of, has 360 degrees. If it was a regular quadrilateral, meaning it's a square, I would take 360 divided by the number of angles, which would be 4. Okay, so every angle in a regular quadrilateral has to be equal to 90. Okay, again, there's 4 angles. The number of angles is going to be the same as the number of sides. which is called n. Okay? Let's look at a pentagon, which has 5 sides. And up here, they have drawn 2 diagonals, okay, which created 1, 2, 3 triangles. All right, so if I look at this pattern so far, okay, I have increased my number of triangles by 1, right? So I know it's going to be 4, 5, 6, so on and so forth. And right here, every time I'm increasing a triangle, I'm adding another 180 degrees to the figure. So if I take 360 and there's another triangle, right? I'm going to add 180 to that and I get 540. You could also think of it as, well, if there's 3 triangles, right, and they all have 180 degrees, 3 times 180 is 540, okay? But let's kind of look at the pattern straight across, right? So these are increasing by 1, these are increasing by 180, okay? This is not going to increase by 30 every time. Remember, I'm going to take that sum of my interior angles and divide it by the number of angles or sides, which would be 5. That would be 108 degrees, okay, if it was a regular pentagon. Okay, but let's look at this pattern straight across. If I have 3 sides, I have 1 triangle. If I have 4 sides, I have 2 triangles. If I have 5 sides, I have 3 triangles. If I have 6 sides, I have 4 triangles. If I have 7 sides, I have 5. So if I look at the relationship from 3 to 1, 4 to 2, 5 to 3, so on and so forth, I'm taking the number of sides and I'm subtracting 2 every single time. Okay, so I know it's going to keep increasing by 1 triangle. But if I have a number of sides and I subtract 2, that's going to give me the number of triangles. And I know that every triangle has 180 degrees. Okay, and we were increasing that by the number of triangles, right, or the 180 every single time. So if I'm kind of just thinking here, for any polygon, I would take the measure of the angles of one triangle, 180, and I would multiply it by the number of triangles, which is n minus 2. Okay, so here are the rules for any, we call it an n-gon, right? The number of sides times, or, you know, with gon, right? We'll kind of finish that table here in a second. N represents the number of sides, which is also going to be equal to the number of angles. The number of triangles, we had to subtract 2. The sum of the angles inside, well, that depends on the number of triangles, right? 180 degrees for every triangle times the number of those triangles, which was n minus 2. So here is your rule for the sum of the interior angles of a convex polygon. This applies to any polygon. It does not have to be regular. 180 times n minus 2. Okay? If I wanted to find one angle, that polygon has to be regular. Okay? If they're going to all be the same, right? If it says find the measure of one angle of the regular polygon, well then I take this sum and I divide it by the number of sides. Okay, so let's just talk about some names really quick and then we'll move on. And like I said, we'll fill out some more of this table, but not the entire table. So after pentagon, 6-sided figure would be a hexagon. It has 4 triangles. If I take 180 times 4, I get 720. If I take 720 and I divide it by the number of sides, which is the same as the number of angles, one angle would be 120 degrees. Okay. 7-sided figure is called a heptagon. Heptagon. Okay. There's n minus 2. 180 times n minus 2 or 5. My sum of any heptagon is 900 degrees. If it was regular, I'm going to divide that by 7, and every angle would be approximately 128.57. 8 would be octagon, like a stop sign. Okay, 180 times n minus 2, or 6, the sum would be 1080. If it was regular, divide it by 8, the number of angles or sides, and that's 135. Okay, so the same process for the rest. I'm just going to finish out the names. Just these are names that you will need to know, 3 through 12. So 9 is called a nonagon. 10 is a decagon. 11 is a hendecagon. And 12 is a dodecagon or dodecagon. Okay, so those are some names that you might see on questions, right, in your homework, quizzes, or tests. So I would make sure you're familiar with most of these names, and then after we, surpass 12, if it's 13, we just call it like a 13gon or a 14gon, right? That would be the number of sides for those types of figures. Okay, so sum of the interior angles, 180 times n minus 2. Okay, so let's do some examples. We will definitely have a part 2 of the video since the first page took almost 12 minutes. Okay, so it says a convex polygon has 13 sides. So I'm going to write n is equal to 13. Find the sum of the measures of the interior angles. So we know that our sum is equal to 180 times n minus 2, right? That was the rule. Well, n is equal to 13, so 180 times 13 minus 2. Remember, I always simplify what's inside the parentheses first. 180 times 11. Okay, 13 minus 2 is 11. So when I multiply 180 times 11, I get 1,980 degrees. That is the sum of the measures of the interior angles. All of the angles inside of a 13-sided figure add to 1980, whether it's regular or whether it's just a, non-regular convex polygon. Okay, when I have a question like number 2, all right, we'll do number 2 and then we'll move on to part two of this video. Find the measure of each interior angle of pentagon ABCDE. Okay, so don't get this confused with what we did in this table right here with one angle, okay? And we will always clarify on your question if it's regular or not. Clearly, these all have different measures, right? 4x plus 10 is not the same as 7x or not the same as 4x plus 5, okay? X has to be just whatever x is equal to, right? X does not change. So the way I know that these are all different angles is because they have all different expressions, okay? It could come out to be something of the same, but we will always clarify in the question of regular pentagon, ABCDE, but this is not regular. But what I do need to first find is, well, what is the sum of the measures of the interior angles of a pentagon, right? It was 540 from our table. Okay, so I know that the sum is 540. What I have to do to find each is, well, I need to solve for x first. So I'm going to add all of these angles together. Okay, let's start with all the x's. 7x, 4x, 4x, 5x, and 6x. That gets me 26x. Then I have 10 plus 5, that's 15, minus 5, that's 10, plus 10, that's 20. So all of these angles added together gets me 26x plus 20. When I add all these together, that gets me the sum, which I know is going to be 540 degrees in a pentagon. Okay? When I solve for x, 26x, if I subtract over 20, gets me 520. Divide by 26, that means x is equal to 20. Okay, I'm going to pause right here and continue this question on part 2.